Hi, my name is Ram Devinder Khambamettu, and this is my final project, case study in recognition of emotion. The objective of this project is to recognize emotions in human faces. We have millions of images online of human faces, and it's very easy for humans to recognize an emotion in human face, but not for a machine. Now, we would like to train to recognize emotion in human face for a machine. We will use convolutional neural nets, and we will use Google Collaboratory for faster processing. We will use Keras, Python, deep learning libraries extensively. This we found the data, we downloaded the data from Kaggle challenge, and it has 35,000 images, and we have distributed it with 28,000 for training and 3,500 images for validation and 3,500 for testing. And these are the software and technology what we have used: Google Collaboratory, Python, TensorFlow Keras, Jupyter Notebook, Matplotlib, Pandas. Here Google Collaboratory was very efficient and was very helpful. On my machine, which is of 16 gig i7 process, it was running per epoch, it was running for 30 minutes, whereas Google Colab, it completed in 1 minute. I was really impressed, and I continued using it, and it was very good, and I could run multiple times, and it was very helpful. And this is my machine configuration. It has 16 gig, and it was a good machine. And this is the dataset what we have downloaded from Kaggle. It has 3 columns: emotion, pixel, and usage. Emotion has 0 to 6 values, representing 0 angry, 1 disgust, 2 fear, 3 happy, 4 sad, 5 surprise, 6 neural net emotions. Pixel, image in pixel numbers. It contains a string of numbers which represents a pixel numbers of the image. Usage, dataset to be used for training, private test, or public test. And this is the sample data what we have: emotion, pixels, and usage. We can see emotion 0, which is angry, and this is the pixel numbers of the image, and this belongs to training dataset. In the same way, we can see number 2 represents fear, so fear, and this is the pixel numbers, and this belongs to training dataset. And 4 represents sad, and sad, we have this string of numbers representing pixels, and this belongs to training dataset. And these are the overview of the steps. Set up Google Collaboratory, download the data, clean and load the data, use image data generator, sequential model, convolutional layer phi, and fully connected layers phi, compile, fit model, evaluate. And this is the Google Collaboratory. It's very easy. We just need to follow the instructions from there, from this URL, and we can actually connect or mount our G drive to it, and I was really impressed with this. And these are the imports, the libraries what we have imported, and these are all the required libraries. And this is the loading the data set. We have used pandas to load the data, and these are the images what we have just loaded. They are of 48 by 48 size, and they are of grayscale, and we can see the images. They're a little bit blurry, and we can still identify the emotion recognize the emotion. Now we will train our machine to recognize the same. Like this one, the middle one, this sounds scary, and this is neutral, and this is tense. Let's see. And now these are the classes, a number of images per class in the training dataset. We have angry images of 3995, and disgust, number 2 is fear. Fear, we have 4096 images, and 4 is sad, we have 4830 images, and 6 is neutral, which is 4965 images. 3, which is happy, we have 7214, and 3170 is of 5, which is surprise, and 436 is of disgust images. But looks like we have more of happy images, 7214. And we have used image data directory, the data generators, because we want to feed our model with the batches of images. So we will be using data generator. Data generators are very useful when we have to feed our model with a batch size, continuous batch size. So here we have the batch size. We set it to 128. I tried with 128. I didn't try with anything else. And the class mode is categorical, and we have total of 28,706 images belonging to 7 classes. We have this in this train generator, and this is randomly the batch sizes are set, and it's very efficient for convolutional neural nets. And this is the other data directory, data generator, what we have used for private set. And this private set, this we will be using for validation data set. And this has 3589 images of total 7 classes. And the target size is of 48 by 48, and the batch size is again 128. We will follow the same approach what we did for input for the training data set. And this is the first sample conv layer. We have 5 conv layers and 2 fully connected layers. And this is as this is a sequential model, we start with conv 2D 64 and 3 by 3, and the padding is same, and we have activational ReLU activational function. We have max pooling or 2D pool size 2 by 2, which is the stride size of 2 by 2, and the dropout is default 0.25. This is for performance. And batch normalization, this is very efficient, and this is for our fully connected layer, where we have dense 256, and again activational ReLU activation, and dropout is 0.25, and batch normalization function we used. And when we compile, we use categorical cross entropy for loss function, and Adam optimizer, the first optimizer. And once we build a model, the summary, it was a very big model, so I just put the last few lines. We have total 3 million parameters, and we have trained 3 million parameters, but we still have around 4,000 non-trainable params, which we just wanted to ignore and move forward. And finally, we have once we fit the model and with the data generator training and test data set, this is the plot what we are seeing, loss and accuracy. And loss and accuracy, the validation loss or the training the testing loss, and the training loss. This represents slowly the training loss is coming down, whereas the testing loss is actually consistent, I would say. And here also it's pretty much consistent. And finally, we have an accuracy of 64%, which for image processing, I feel which is good. And we have used the test generator. Here I just want to mention we have used a different data set, as we distributed the data set into 80, 10 and 10. 80% for training and 10 for private test and 10 for public test. And I'm using this public test as test generator, and we are using this for the test generator, and we have 64%. Thank you.